But if you close your eyes,
hey guys, today we're going to be talking about density. So when you look up density on Google, what you get three definitions. One is the regular definition, one is the computer definition, one is the physical definition. For the computer definition, we don't need it because it's not what we were going to cover for Q&A ready. So for the regular definition, it says the degree of compactness of a substance. When it's talking about the degree of compactness, I mean how much matter is in something. As you can see, it says solidity. Solidity means how much of something is in a specific substance. So like the loss of bone density. Bone density means the density of the bone. So how much something is in that bone. The heart rate. Yeah, I think that's covered. So in physics is a degree of consistency measured by the quantity of mass per unit volume. So what they're saying is the degree of consistency is saying how much of something is measured by mass divided by volume, mass per unit volume. So what it's saying that to find density, you have to find the mass and the volume so it can be divided into density. So then it says the opacity of a photographic image. The opacity of a photographic image. So I don't think that covers about density. It has to do with this. But what this is trying to say is how much the image takes up. Or like how much of the image is taken up. So then back to the subject is the quantity of people or things in a given area of space. So areas or space meaning volume, and people or things meaning mass. So what it's trying to say, how much mass is in the given volume. So to find the density, you have to find the volume. So now for volume,
volume.
Okay, the volume is giving us three definitions. So the first definition says a book forming part of a work or series. So that kind of talks about, but it's not what we need to cover. It's saying that the book is taking part of the work or series, but it's not what we need to cover. So then it says number two actually does actually talk about what we need to cover. It says the amount of space that a substance or object occupies or that is enclosed within a container, especially when gray. So what they're saying is the amount of space an object is taken up, occupies. And then it says or that is enclosed within a container. So saying not only the container can take up stuff, the stuff within the container can take stuff. So like the liquid, for example. The liquid is not an object. So and then it says especially when great. So that seems like the capacity of the capacity of the water, like how much does the water take up. The next definition says the amount of quantity of something, especially when great. Amount of quantity is something, is saying how much does something take up. So how much does matter of something is taken up. So measured portion, something like that. So a certain typically large amount of something. So the volumes of data handled are vast. So it's taking up, again, large amount of something. Then fullness or expansive thickness of something, especially of the person's hair. Well, of the person's hair think that's too descriptive, but I'm gonna manipulate the definition and use it on my own terms. So fullness or spaciness, thickness. So they're saying how much it takes up the hair, basically, of something. So it's going back to number 2. They're saying quantity or power of sound, degree of loudness. So let's talk about sound, and we don't need to cover that. So when studying for the TN ready, you can look up volume and go to the definition number 2. So as of mass, when you look up mass, it gives you 2 definitions: the noun and the adjective and the verb definition. The noun definition is a coherent, typically large body of matter with no definite shape. So what that's saying is, within the shape that doesn't have to be definite, right? Like it could be any shape. It could be like a human hand, or it could be a speaker. It has matter. So everything that has shape has matter. So everything that is something has that. Matter makes up everything. Then it says a majority of. We're saying that the majority of the matter, the majority of the mass is blah blah blah. Then for adjective, it's saying relating to, done by, or affecting large numbers of people or things. They really have mass here, so that's not getting back to science and stuff. And then verb, assemble or cause to assemble into mass or one by. So what this is, when you assemble or cause to assemble, you're putting the matter together to create more matter. With them not big. So basically, mass is the matter mass is matter within the shape. So right now, I've lost your attention. Well, I lost your attention 5 minutes into this video. So as a reward for staying tuned, I'll stop with the information and show you how to utilize it. We have a cube, and we need to find the density of it. On the TN ready, they'll give you the measurements of all the faces. But for the sake of this video, I'll show you how to find them so you can determine the volume. First, measure the X, Y, and Z axis. Or if you've been told, find the length, width, and height. So, since we know it's a perfect cube because it says so, by finding one side is good enough. If it wasn't a perfect cube, you have to find all the measurements or sides. So we know all the sides are 5 centimeters long. So to find the measurement for volume, we'll have to multiply the sides. If you know how to find the area of one face, then you won't struggle finding the volume of the entire thing. So 5 centimeters times 5 centimeters times 5 centimeters is 125 centimeters cubed. So the perfect cube has a volume of 125 centimeters cubed. You may ask yourself why the measurement is cubed, and that's because the power of 3 represents how many times centimeters is being multiplied by itself. However, this method does not apply to all objects. For example, when trying to find the volume of the liquid is poured into a graduated cylinder, and the scale of the lowest part of the meniscus to determine the volume, or trying to find a volume of an irregularly shaped solid object. The water displacement method should be used. You might be asking, what is the water displacement method? Well, it is a simple method which requires a graduated cylinder, water, and a little bit of thinking. First, measure the initial water, which according to this graduated cylinder is 100 milliliters or 100 centimeters squared, because 1 milliliter equals 1 centimeter squared. That's why this method is so useful. So, after measuring the initial volume of the water, the irregularly shaped object is dropped into the graduated cylinder. When it's dropped, the level of the water has gone up. That's because the object has volume, which occupies space in the water. Then we measure the final level of the water after the object has been dropped, and it's 115 milliliters. So the irregularly shaped object has a volume of 15 milliliters or centimeters squared. The next step to finding the density is finding the mass. In finding the mass, don't get it confused with weight. Before informing you how to find mass, I'll explain the differences between mass and weight. Mass determines how much matter is in an object. For example, a ball has matter. The amount of matter the ball has is less than how much matter you have. And that is why you have a bigger mass. But one thing you both have in common is that no matter where you are in the universe, you have the same mass. To illustrate, let's say a ball is on the top of the hill with a mass of 2 grams. Then it rolls to the bottom of the hill while maintaining the mass of 2 grams. Soon, it gets sent to the moon, and even though there is a little gravity, the ball still maintains its mass of 2 grams. However, this principle does not go for weight, because weight is the measurement of the gravitational impact on an object. Gravity keeps things from floating out to space, and even though mass has an impact on weight, weight does not impact mass. For example, the more mass an object has, the greater the gravitational force on that object, and the greater the object's weight is. That's because the gravitational force between two objects depends mainly on distance and mass. That's why, depending on your location or distance from an object, the weight changes. So finally, to find the mass, one needs a balance. The balance helps because it measures the amount of matter in an object, and wherever you measured it, it stays constant. Ultimately, remember to set everything to 0 before starting to measure the mass, and then, after placing the object down, make the 2 lines connect and record the data. Before we finish, the values for mass and volume need to be plugged into the equation. After plugging in the 125 cubic centimeters for volume and the 5 grams for mass to the equation mass divided by volume equals density, we find the density for this perfect cube is 0.04 grams per cubic centimeter, which says a lot about this object. For example, since it is not that dense and the mass is only 5 grams, then the average human could possibly lift it. We can also tell that since its density is less than 1, it will float on water. Also, since we know if you pour multiple liquids with different densities on a graduated cylinder, they will arrange themselves in order from the least to greatest of the density, then this subject might maintain probably between the top liquids. Finally, I'll leave you guys with a 10-question quiz that will sum up everything we learned.
you.